So, today we're going to start talking about section 4-3, which again, we're dealing with shortcuts to prove triangles are congruent. So, we have currently two shortcuts. So, let's see, I'm going to call these triangle congruence shortcuts. We have two of them. Which ones? Which ones do we know? Which ones have we been using in the last assignment? Side, and side, angle, side. Those are the two that we know. Today we're going to add two more to those. Now please remember, side, we're literally saying that we know all three sides, right? The three corresponding sides. Side, angle, side means that we know two sides of the triangle and we know the angle that's between them. Right? Well, today we're going to add two more. We're going to add one called angle, side, angle. And then we're going to add one called angle, angle, side. Angle, side, angle. Let's talk about that one quick. For angle, side, angle, you know, literally, again, we call it angle, side, angle because we know two angles and the side that is between them. Okay, just like in this diagram. I know this angle, I know this angle, and I know the side that's between the two angles. I know this angle, I know this angle, I know the side that is between the two angles. So that makes these two triangles congruent by angle, side, angle. Okay? Now, if you think of this, well, how could that work, or why does it work? Well, if we have a side length set in stone, like I have maybe a 2x4 that's 4 feet long, okay? If I'm trying to construct a triangle that's the same as, say, another triangle, if I go through here and off of that 2x4, if I measure an angle that's, say, 60 degrees, that's going to give me a certain place to put my other 2x4 or other board, right? So I have that set 2x4, measure 60 degrees, I know I have to go at this angle. Correct? All right. And then let's say I have some other 2x4 that I'm connecting to the other side of my 4-foot 2x4. And let's say we make that, I don't know, 40 degrees. Okay, if I measure then 40 degrees up from this, I'm going this direction now. And 40 degrees, it's going to bring over here, I've got some other 2x4 going on there. Connecting that at the bottom. There's only one way I can do that. This one only can rotate up so far. This one can only rotate up so far. I would then connect those up here with nails or screws or whatever and lop off the excess, right? I mean, that's how I do that. And I could reproduce that triangle over and over and over again. It would be the same triangle. If I start with a 4-foot 2x4, measure a 60-degree angle, measure a 40-degree angle, and connect those boards, it's the same thing every single time. Okay? It's going to be the same thing every single time. So, angle, side, angle is a shortcut for showing triangles are congruent that we can use and will use. Any questions on how or why? Everybody okay with this? Let's take a look at the example right next to us here. Which triangles are then congruent by angle, side, angle? Okay, the first and the second. Can you name them for me?
Triangle UVS and triangle ON.
Triangle UVS is congruent to triangle, say that again?
ONE.
No.
No. How's that not right?
Okay, is he talking about the right two triangles?
Yeah.
Yes. Angle, side, angle. We need to know two angles and the side between them. So we have the same two angles and the side between them. But what is he doing wrong? Go for it.
It's in the wrong order.
You have to name congruent triangles using the proper corresponding order.
I forgot about that.
Triangle EON. Perfect. That is the way that we should name the triangles. You have to have your corresponding parts in the right spot. Okay? Questions? None? Let's go ahead and take a look at the other theorem then, because we have some proofs here we can work on, but let's make sure we know our theorems first before we talk about our proofs. So, taking a look at the next theorem we have. This one is angle, angle, side. Angle, angle, side. So an angle, angle, side, again, you can tell by the way they name this, we're talking about knowing two angles and a side of the triangle, but it's not between the two angles. Okay, so before we had angle, side, angle. It was two angles and the side between them. Now we have angle, angle, side, which means we have two angles and a side that is not between them. Here you have to be careful. Order matters. Okay? Order matters. It cannot just be two angles and any of the sides. Because if you look down here, our triangle, we have two angles, of course. We have our red angle here, and we have our blue angle up here. Okay? So the side that's between them is this side here. Right? That's the side between the two angles. That's not the side we want, obviously, because we're not using angle, side, angle. Correct? Okay. That then means that we have two different options for the side that's not between them. BC and AC. Those are sides that are not between our two angles. It is a different situation. If you come in here and say that you have the two angles and side AC congruent to side EF, right? If I have two triangles here, and I know that this angle is congruent to that angle, I know that this angle is congruent to that angle, and I know that this side is congruent to this side. I know two angles and a side that's not between them, so I have an angle, and a side, but it's the wrong side. This side comes off of that single marked angle. This side comes off of that double marked angle. It's the wrong side. It's not in the right corresponding position. So these guys are not congruent by angle, angle, side. Okay? They are not congruent by angle, angle, side. In order to be congruent by angle, angle, side, it has to be like the situation above, where our side is coming off of that red marked angle. And in the other triangle, that same side is still coming off of that red marked angle. It's in the appropriate order. Okay? Yes, ma'am?
Could it be the same thing, just like if they were both off of the double?
Absolutely.
Okay.
Absolutely, yeah. As long as they're in the corresponding positions. Yep. Yep, and the way I like to do this, if I'm testing, I know it kind of makes the diagram look all sorts of nasty, especially since I already marked it up. But I like to go through and start with my angle farthest away from my side and say, okay, I've got whatever single or double mark, there's my single mark, and then here's my side. And go to the other triangle and say, okay, where's my same double mark, yep, I can go to my angle, and then right off that's my side. Just making sure that they're all in the right order. It doesn't matter if it's coming off the single mark or double mark, because in every diagram that gets marked differently anyways. Okay? It's just you got to make sure that they're in the proper order. That the side that you know is coming off of the same angle in both triangles. All right. So that is angle, angle, side. Any initial questions there? Okay, and that's how they describe it here. If two angles in a non-included side of one triangle are congruent to two angles and the corresponding non-included side. That means it's got to be in the same position as in the first triangle. Okay, let's take a look then here. We want to know, is triangle PAR and triangle SIR congruent? Explain. How do we know? Do we know? Can we say it? What do you think? Charles is saying yes. Why?
I'm not saying anything.
You can.
Why?
Because, like, PA is the same as SI.
PA and SI. How do you know that PA is the same as SI?
Because they have the same angle.
Nope. There is actually no way for us to say that.
There isn't?
No. No, because those two sides, this side here and this side there, just because they come off the same angle does not mean that they're going to be congruent. I could have a side come off of a 90-degree angle or a side come off of a 90-degree angle. That side doesn't have to be the same length. Right? Yes, sir.
Can we say that angle SRI and ARP are vertical angles?
SRI and ARP. We most definitely can say that those are vertical angles. Okay, so you're telling me that yes, we can say these triangles are congruent?
Yeah, because angles.
Because angle, P, angle PRA is congruent to angle SRI. And therefore, we're able to say what?
Angles.
Therefore, they're congruent by angle, side. And again, you want to double check that they're in the right order. So I come over here, what do I know? I've got my angle, and then that side. On the other side, I can go through and say, yep, I saw a single mark to the double mark, then there's my side. So I know it works. I know they're in the right order. Questions? All right, so we want to do a proof here. Let's start out with this one, because this one's kind of different than some of the rest. It has that extra information that doesn't go into the same structure as everything else. So, looking at this one, we're proving triangles are congruent. So I want to have my basic structure. There's my basic structure. I'm showing that triangle WMR is congruent to triangle RKW. My three known pieces have to be, I got them written on the board over there, they have to be either three sides for side, 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 two sides and the angle between them for side, angle, side, two angles and the side between them for angle, side, angle, or two angles and a side that's not between them for angle, angle, side. Now, of course, in the instructions on this one, they tell us which one of those to use. They say use angle, angle, side. So we've got to find two angles and a side that's not between them. Well, our first given is that angle M is congruent to angle K. Are those angles in our two triangles we're trying to show are congruent?
Yeah.
Yes, so those go in those spots. So we have angle M is congruent to angle K. All right, but the next given is that line segment WM is parallel to line segment RK. Is that telling me angles or sides being congruent? Does that go in those three spots?
Yeah.
No. What I mean by angles or sides being congruent is that it literally has to say that these two angles are congruent, and they have to be angles of our triangle, just like we did with M and K. Or it has to be these two sides are congruent, and they have to be sides of our two triangles. So this does not tell us directly sides or angles of our triangle, so this has to come outside. Line segment WM is parallel to line segment RK. But what is that going to tell us? So we got to stop and think. If they're giving us parallel lines, they're trying to tell us what?
You could use the alternate interior lines.
Yes,
Angles.
alternate interior angles. If they give you parallel lines, they're trying to tell you that angles are congruent. Anytime they give you parallel lines, they're trying to tell you angles are congruent. Now, we had 4 theorems in a postulate about parallel lines and angles. Only 3 of them gave us congruent angles. Okay? But I'm going to tell you right now that when we're doing triangle proofs, 9 times out of 10, they're going to be telling you that the angles are congruent because that's what we're looking for. We're not looking for angles being supplementary. Okay? So you need to be looking for corresponding angles, you need to be looking for alternate interior angles. Once in a blue moon, it might throw out alternate exterior angles, but it's probably going to be corresponding or alternate interior. In which case, the alternate interior angles here are what?
KWR and WRM.
KWR, and so KWR, and what other one?
WRM.
And WRM. No, actually. Are those angles alternate interior angles? Yes. Are those angles congruent? I can't tell. Why? Because these segments are not my parallel segments. So that is a common mistake. You've got to make sure when you're looking for alternate interior angles that you are actually picking the sides or angles formed given the parallel lines. So we have to use this segment and this segment, meaning I have to use this transversal, giving me angle MWR congruent to WRK. Okay, and we know that because they are alternate interior angles formed by parallel lines. So that is the alternate interior angles theorem. All right, well, we need one more piece of information. We currently know 2 angles. Quick question for you. If you're not sure where to go, if you're not sure what you're doing, we should at least be able to narrow it down. Am I looking for a side or am I looking for an angle? Looking for a side, absolutely. How do I know? Because there is no such thing as an angle, angle, angle triangle shortcut, congruence shortcut. Okay? The way I like to remember that is that angle, angle, angle only works for cars and batteries. AAA batteries, AAA is the, yeah, you get it, okay. Cars and batteries, that's all AAA works for. Okay, it does not work for triangle shortcuts. So don't look for AAA. And like I showed you guys last week, I showed you that's 60, 60, 60 triangle, right? Okay, we call that equiangular. That's a vocab word we'll talk about in the future. But I showed you that triangle drawn 3 or 4 different ways. Really small triangle with all 3 sides being 60 degrees, or a really big triangle with all 3 sides being 60 degrees. So angle, angle, angle does not guarantee congruent triangles. So in our case, we know we have to be looking for a side, and therefore we know it has to be which side?
WR.
Line segment WR. Has to be congruent to itself. How do we know it's congruent to itself?
The reflexive property.
We call that the reflexive property. Okay, so now our 2 triangles are congruent according to what? Angle, angle, side. Very good.
Please send Elise.
All right, so looking back at your front page here, let's take a look at this proof. So here you got to be careful because looking at the diagram, you can tell me already that we're going to use what? Careful, do I know 2 sides? It's going to be angle, side, angle. You guys can tell me that already just by looking at the diagram. But you've got to be careful at what you're given and how you're going to use it. So we can say some stuff already. We should be able to get lots of partial credit on this proof, even if we don't know how to do the total proof. Okay, because I should be able to say that triangle ABC is congruent to triangle AED. And looking at the diagram, I know that I'm going to be able to do that by angle, side, angle. So I can already fill in my reason there. Okay. I know that angle CAB is congruent to angle DAE. It's marked in the diagram, and I need that information for my triangles, so that goes in one of these spots. I know that line segment BA is congruent to line segment AE. Again, parts of my triangle, so I need that. It goes in one of these spots. And you would like to say that angle B is congruent to angle E, except that's not what they gave you. They gave you that angle B and angle E are right angles. That does not go in those spots. No. The only thing that goes in those three spots are congruent angles or congruent sides. Midpoints, bisectors, the fact angles are right angles, none of that stuff goes in those three spots. Okay, but there is a theorem that we used way back in Unit 1. We talked about it. It's actually Chapter 2, I believe. And we talked about it. We named it. I can't think off the top of my head what the theorem number is. I want to say it's Theorem 2-3-ish in that area. But anyways, we named that one. We named the theorem saying that if we know that angles are right angles, that tells us those angles must be congruent. It's exactly the right angle theorem. So the right angle theorem tells us that if we have right angles, then we know they're congruent. So we know that angle B is congruent to angle E. It has to be. Okay? And so that then is, I forgot to write my given here. That's given. That is then enough to fill out our flow chart. Okay? That is now enough to fill out our flow chart. Questions? Nothing yet? Again, it's really more of the same, right? We're just still doing the same proofs. We're still working with flowchart proofs. Correct? Okay. And so what we want to do then is just use our two new theorems that we're dealing with. And those two new theorems was that angle side angle and angle angle side. Please remember that on angle angle side, the order matters. Order matters on angle angle side. All right, any questions?